Hello, everyone. Welcome back to the main stage here at the Women Tech Global Conference. We are so happy to once again have you joining us. We have a few more speakers still today, so don't go too far. Right now, we have back-to-back some amazing female leaders from across the world. The first one joining us right now is going to be Chen. Yan is with Huawei Technologies in Shanghai. And I'm going to bring her on the stage. Hello, Yan. How are you today?
Hello, everyone. Hi, I'm Chen from Huawei.
Hi, Yan. So this is Yan. She started with Huawei in 2009, where she was a project manager and technical leader of Huawei International Green Radio Project, studying energy efficient solutions for wireless networks, and also served as the technical leader of their green transmission technology project. So marrying some different worlds there of looking at green tech and looking at future of tech. And since 2013, she is one of the key technical leaders on 5G air interface design and the related 3GPP standardization they had in Huawei. But now she is leading the 6G vision study at Huawei. And this is exciting, Yan, that you're here today to talk to us specifically about this 6G journey, because I feel like we only just finished talking about 5G. So super excited to have you here telling us about more of these future technology trends and opportunities that we have as we move forward. So Yan, I'll let you take it away.
Okay, thank you very much for the slot, and it's really my honor and pleasure to be here, and especially as a woman, Women in Tech, the global conference, it's really a great honor, and thank you very much. Okay, so before I share my slides and to start this journey of 6G vision, I would like to introduce a little bit more about my experience in Huawei, and especially the experience in the 5G research and the standardization. So as you just introduced, I joined Huawei in 2009 after I got my PhD in information and communication systems. At that time, as a researcher in the theoretical problems, so my professors just asked me, how are you going to survive in industry in a company like Huawei? So I said, okay, that's exactly the thing I'm going to find out. I would like to enjoy the whole process to put all this concept from this theory stage to the practice. So that's something I really want to go after. So that's why I joined Huawei without hesitation, because that's the best company in ICT in China. And then so it turns out the join time is really good, because when I joined Huawei as a junior engineer, I got the chance to participate in the international platform, the Green Touch, to do this energy efficiency studies. And then I'm really lucky, because at that time, around the 2009, it's actually the timing that Huawei started to look into the vision of 5G. We started internal discussion about what the next generation of mobile communication would have at that time of 5G. So around that time, people are not really believing that there will be a 5G. So people were saying, wow, 4G works well, and why we need 5G, right? So at that time, I was really lucky that I was participating in this very initial concept developing of what 5G will bring, the target setting, and then also the key technologies developing, especially to accommodate large number of access of IoT devices, which will make it different from the 4G. And then at that time, we also do the prototype to justify this concept we built, the technology concept we built, and also build the lab tours to show the concept to our customers. And also we put all our technologies and the concept into the field to test with multiple base stations and lots of user devices. So, and then finally we go into the 3GPP standardization progress. So I'm so lucky that I go through all of them. And I learned a lot from the colleagues and the experts in the projects, we have hundreds of people working on the 5G research. That's even before the standardization. And then I feel that this experience in Huawei really makes me feel at worse, because inside Huawei, this research environment is beyond my expectation when I was a PhD. We have a team. So here we evaluate teamwork a lot, and we evaluate innovation, and also the collaboration and hard working. So that's why I encourage most of the PhD students, if you want to try some industry experience, and if you want to try to put your concept from theory to practice, you should try to join us or trying to come to the industry. Okay, so maybe it's time I go into this presentation of what 6G will be look like. Okay, I will switch to the screen. Can you see the screen now? Okay, hopefully. Then I will continue the presentation. So now we are, this commercial deployment of 5G is accelerating, right? So 6G becomes the next generation. And also we are also hearing a question about, do we really need a next G? But this time it's better, because globally, different companies, different platforms, different regions or countries are all looking into the next generation. It takes time to really doing the research and to find out what is possible, and to have the common understandings of what will be the most important things to address in the next 10 years. So that's why it's not early now to start the whole 6G research and vision definition. Okay, so our vision is that 6G will bring this connection from connected people and things to connected intelligence. Okay, I will explain that more. So, up to 4G, it's we really can have this connected society that people can really send their messages and their videos and pictures everywhere. So we feel very connected in a society. It takes almost 2 decades or 4 decades if you counting from early 1980s. And then 5G, we set a goal that beyond connecting people, we're going to connect everything, right? So around the 2020, we started the commercialization of 5G, and then we are looking into connecting more and more different types of things, and we are pushing this 5G not only to serve consumers, but also to do the digital transforming of different vertical industries. So this is the era of connected everything. So we beyond the mobile broadband, we add new services or usage scenarios called URLC, ultra reliability and low latency communication, and also massive machine type of communication, which is MMTC. And we are extending the bandwidth we use from the very low bandwidth, like sub 3 gigahertz, to around 6 gigahertz, and then up to millimeter wave. And now we are looking into the year of 2030 and beyond. We are thinking that what will be the paradigm shift beyond the connecting everything. So one thing is we can see the trend of intelligence coming, because AI is developing very fast and it's going to be used in everywhere. So this intelligence will evolve, even it's regardless of the evolution of the ICT. So how this mobile communication networks will play a role in the era of intelligence. We think we will not only connect people and things, but also connect intelligence. So how are we going to do that? We think there are 2 big usage scenarios beyond the 3 usage scenarios we just mentioned: the EMBB, the mobile broadband, the URLC, the very critical services, and the MMTC, which is a massive machine type of communications. Beyond that, we are adding 2 new usage scenarios. One of them is sensing, and the other one is AI as a service. So what is sensing mean? Sensing means that currently the radio waves, it's only used to take the data from A to B, right? So we transmit a package in on top of these radio waves, so you can wirelessly receive the data and decode it and get message. Okay, while this data is transmitted over the radio waves, the radio waves can also do another thing, which is it go through the environment, go through the channel. So it actually can seize the environment in the channel. So by analyzing this, the reflections, diffractions, and all the echoes in the environment, we can actually analyze a lot of information of the environment. Like we can model this. We can tell the distance, we can estimate the velocities, the angles of different objects. So that's the capability of sensing. So with the integrated sensing into the communication, we can provide new scenarios to the 6G systems. So 6G can provide new services. Okay, and then for the AI as a service, first the AI can be used to facilitate the communication, can make the communication to be more optimized and more autonomously optimized, right? But it can also do something else that the whole network can use to support the larger scale AI learning and inference. So I will explain it more in later. So these two are the two new usage scenarios we're thinking will bring the paradigm shift into 6G that will make the a new generation in 10 years to come. Okay, so just give some examples of the use cases under this 5 big categories of 6G usage scenarios we proposed. So it's many people are talking about AR, VR, right? And then we are hoping that currently we are using VR only for the entertainment, for the games. But in the future, we are thinking, okay, we are gonna have the metaverse. If we are gonna to have the metaverse, we will using this AR, VRs for a very long time. It will become naturally part of our lives, right? So that means we will wearing this glasses. Also, it will change. It will be very lightweighted and very comfortable. And then we will using it just like using our eyes. So we need to make sure this resolutions of these glasses and this AR, VR things can just go to match our eyes, these perception limits. So that's why this we call it immersive experience of this XR. And in order to do that, we need to have a much higher throughput and a much lower latency. That's why it gives the very hard challenge on the communication performance. So that's why we need more advanced communication technologies to do that. That's one example. And the other example is that currently the eMBB services are very good in the cities, right? But if you go to suburban areas, the connections are not so good. This is not a fully technical problem. It's mainly an economic problem because the operators cannot gain enough revenue by deploying many base stations in the suburban areas, right? But if there are any other technologies will help them to make more to solve this problem, to connect the unconnected areas, and then there are still more than 3 billion people are not connected. How can we do that? So we are considering one possibility is to have the non-terrestrial networks like this satellite communications to be integrated part of the 6G communications. And by satellite, we are talking about this very low orbit very low Earth orbit satellites, which will have mega constellations around the Earth, so that this transmission latency would not be a very large issue compared with the geo satellites we are currently mostly used. And also, this throughput will get higher because they will have larger capacities given the new technologies there. Some other examples about this ultra low latency and the reliability communication is about the factory of the future. In the factory of the future, we'll consider about many of the remote control of the machines. And also, more interestingly, we were thinking about using the collaborative robots in the future for many jobs that will be too dangerous for people to do. And sometimes we need the robots to collaborate with human. So currently the robots, when we collaborate with robots, they either work alone or we have a separate regions, right? Robots are working here and people are working in another region. But if we will have this sensing capabilities and real-time AI capabilities, these robots can really, sense the environment, knowing how far the people is, and knowing when they are interacting with people, how tender, how much force they should use, and they will control the things, and then they know where to stop and where they can work, so they can very smoothly work with people to increase the efficiency, and also they can collaborate together in a new dynamic environment to do more complicated jobs. So these are the many new things we think these are the use cases of 6G we're looking into. Of course, there are autonomous driving and many other things. Okay, so give some examples of this enhanced communication. I mentioned it a bit. It's very interesting that from 2G, when we have 2G, we say, okay, if you miss a friend, you say, just give me a call, right? But and 3G, if I miss you, I will send a picture. And 4G, maybe we can make a video call. And in 5G, currently, we are easy to make a video calls, and we are hope to, we can have a metaverse, the initial state of metaverse starting using 5G, right? We can talk in the AR, VR meetings. But in 6G, we can have to work better using these technologies to better support a more immersive experience of working together. And also, when you miss me, hey, send me a hug. Because in 6G, we're envisioning that we are not only to transmit the audio and the video things, we can also transmit what we can feel, the haptic feelings. That will really give you the immersive experience. The COVID thing have separated us for quite some time. And during that time, we really want to give the remote relatives and the remote families a hug. And even without COVID, when I'm traveling around, we cannot be at home, I really want to give my daughter a hug, right? So I'm really looking forward to the haptic communications in the future that could be brought by 6G. So these are the examples of immersive human-centric communications we are looking into, the better performance and the better experience. And as I mentioned, we will have the extended coverage to connect the unconnected, to bridge the digital gaps. And also, on the other hand, we will have, to use in the 6G to make the industry more productive. So this is called the full-scale digital transformation of all verticals. So 5G is starting to do that. And many of the scenarios may not change, but we hope that by developing more technologies, we can do that better and do that easier. So we want to bring this different OTs of different vertical industries to come into the vision definitions of the 6G. So in 5G, we try to do that, but it's still a bit late because we need to synchronize the understandings and synchronize the languages between the communication society and the verticals, right? And then now we have this organization, very good organizations like 5G ACIA, that's different verticals are there and they understand lots of these communication things, and we now understand better these requirements from the verticals. So we are hoping that in 6G we can define the visions together and define the requirements together. So make it the 6G to support the consumers and also these verticals at the starting from the same time. So this will benefit the future manufacturing, the e-health, and many agriculture and many aspects you can imagine. And then these two new aspects, sensing and AI. So as I mentioned, we can gain a lot of information from this the radio waves sensing the signal, sensing the environment. So we have the parameters of the environment, and also we can do the imaging of the environment. So we can have this real-time 3D map or even 4D map of the environment, the radio map for that, and then using that we can facilitate this robot visions or the car vision, the vehicle visions, so that we even without these cameras, even when the cameras cannot work in night or in a very foggy time, then you can use these radio waves to really provide a very good sense of the environment. And also we can get the information of the spectrogram if you really go to the spectrum like terahertz, and then these can be the inputs data for many of the intelligent applications. So the whole 6G network can support to do the distributed learning and the distributed inference, so that even with a limited capability of the devices, we can still benefit from the network to enjoy lots of intelligent applications. So I mean, sensing plus AI plus communication equals new business opportunities. Okay, here we say, okay, because we have these capabilities, it's actually we're gonna to fuse the physical, biological, and the cyber world together. So from the biological, physical and biological world, by sensing and communication, and the learning, we can do the massive digital twin in the cyber world. And from the prediction and the running in the cyber world, we can predict and we can create this virtual environment, and we can provide the inference for the next steps. So these will be our, the real-time massive twinning of the physical and the cyber world. Talking so much now, I'm gonna to show you a video which I directed to show our vision and about these 5 usage scenarios. Let's have a look together.
Radio communication turned its first page when Marconi transmitted the first radio signal across the Atlantic. With the endless frontiers of wireless, spanning 5G, we start wondering what 6G would be like. 6G will serve as a distributed neural network for future intelligence of everything. Network sensing and native AI will become 2 new usage scenarios to fuse the physical, biological, and cyber worlds, leading to an era of connected intelligence. 6G will provide universal high-performance wireless connections with speed comparable to optical fibers. Terabits per second peak data rate, up to 100 gigabits per second user experience rate, and sub-millisecond level transmission latency will enable truly immersive human-centric experience. Further integrating terrestrial and non-terrestrial networks, we can see, touch, smell, and play with family and friends from thousands of miles away, even in the sky or in outer space. 6G will accelerate full-scale digital transformation of vertical industries. In future automated and flexible manufacturing, precise localization and deterministic communication will be provided to support real-time interaction between collaborative robots. Every thinking of network architecture is also considered necessary to enable massive machine learning and knowledge sharing among robots. 6G will continue the journey of connected everything initiated in 5G, but with larger variety of devices, new human-machine interfaces, higher density of connections, and native trustworthiness. 6G will integrate sensing with communication in a single system. Radio waves can be exploited to see the physical world and make digital twins in the cyber world. Such capability offers autonomous driving vehicles ultra-high resolution and accuracy in all weather conditions. What's more, high-precision localization and gesture recognition will truly free our hands and make art creation anywhere, anytime. 6G will boast its native AI capability. Deep edge architecture enables massive machine learning in a distributed and collaborated manner. Robots can thus harmoniously work and play with humans. Meanwhile, End-to-end machine learning will also be leveraged for customized optimization and network automation. 6G is the next horizon of innovations. The ambition of our 6G vision is to make our planet intelligently connected, sustainably developed, better protected, and full of vitality in all walks of life. 6G, the next horizon, from connected people and things to connected intelligence.
Wow, Yan, thank you for that video that you helped produce. Thank you for all of your content here with us today. I think many people in the chat were watching it thinking the future of work is here. So thank you so much for being here with us.